Welcome. In this session, we're going to continue our look at the data types that are available in SQL Server. We're going to start by talking about the character data types that are available and then move into some of the less common data types, those that are less frequently used but still available, and also the ones that didn't fit into any of our other categories, so it'll be kind of a grab bag of the data types that are left. At the end of the session today, we're going to talk about data type conversions, both some features that you can implement when you're converting from one data type to another, and some caveats you need to be aware of as well. All right, so let's get started. First, the data type that we're going to talk about is a car data type. Car data type takes a parameter, an n again. This is similar to the parameters that some of the other data types take that we've talked about, the numeric and datetime data types. The n here indicates the number of characters that you want to store. The maximum number of characters, I should be clear, the maximum number of characters that you want this data type to store. The n can be a number between 1 and 8,000. You can do a car 1 and you can do a car 8,000. So you can pick any number in that range. And because each character takes a single byte to store, the n that you specify also indicates the size of that data type as well. So if you have a car 50, it's going to take up 50 bytes. Now the example that I have here listed in this column, the quick brown fox, has 19 characters in it. So we could fit this in a car 19. But if we wanted to be able to allow longer character strings as well, and we knew that the quick brown fox is one example of a string we might want to store, but we might want to store strings that are longer as well, maybe up to twice as long, perhaps we'd pick something bigger, such as a car 40. A car 40 would hold this phrase, the quick brown fox, just fine because it's only 19 characters. But because a car always takes up n bytes, storing the quick brown fox doesn't take 19 bytes of storage space, it takes the full 40. So whatever n you use for your character string to define the car data type, that is the amount of storage space that it will take for every instance, regardless of what data you put into it. So if you declare a car 50, but only put 5 characters into that variable, or into that column, it will still consume 50 bytes worth of space. Now when we look at the var car, it looks very similar. It has an n as well, and again the n can be a number between 1 and 8,000. Now varchar also has an option for a max. Instead of passing in a number as the defining, you can actually pass in the word max. And if you use max, you can put up to 2 gigabytes worth of characters into a varchar field. Now the storage space is a bit different, and it's because of the differences between a car and a varchar. You notice that they both have the word car, but the varchar has the var at the front, and the var stands for varying. Varying because, unlike a car, a varchar only stores the data that you put into it. So we have the same example here, the quick brown fox, our 19 character string. If we declared a varchar 50, it would store the quick brown fox because that's only 19 characters. But the amount of storage space would be different. In the case of a car, the storage space was 50. A varchar 50, the storage space used would be the actual amount of characters plus a 2-byte overhead. So in this case, if we used a varchar 50 to store our quick brown fox string, it would be 19 plus 2, or 21 bytes. So we would actually save 19 bytes of space using a varchar over a car. When then would you use a car instead of a varchar, or a varchar instead of a car? How do you determine which one you want to use? They both store strings. The only difference is the way they store, or the size of the space that they store. Well, if you're looking solely from a size perspective, it becomes fairly easy because you look at it and say, if all of my data is going to be very close to the same size, every column, or excuse me, every row in my table is going to have a string that it's almost the same length. Perhaps the one that I've seen most commonly are the words insert, update, and delete. Insert is I-N-S-E-R-T, 6 characters. Delete is D-E-L-E-T-E, 6 characters. Update is U-P-D-A-T-E, 6 characters. So you have a column that's tracking changes, and it contains the word insert or the word update or the word delete, it's always going to be 6 bytes. If you declared that column to be a varchar 6, then the actual end of storage space would be 6 plus 2. It would be 8 bytes to store it. If you used a char field instead, then it would just be the 6 bytes. You would actually save 2 bytes using a char instead of a varchar. The other place that I've seen it frequently used is when it's very small, when you only have a single or a couple characters. When you have very small strings, perhaps a status or a gender flag or some other kind of a flag that has multiple values, using a char field, even when you're wasting a byte or two of space, will save the overhead of the varchar. So space issue is one way of determining whether or not you want to use a char or a varchar. The other is the length of the string. If you have a very long string, one that's going to be more than the 8,000 characters that is available in a char, then you're going to need to use the max parameter for the varchar. That gives you the 2 gigabytes worth of characters, which is much, much larger than the 8,000 max for char. So if you need more than 8,000 characters, then varchar max is really the only option. Now you notice that I had a little footnote here, and that there are some performance issues with using a varchar max that don't exist when you actually specify the value. And it actually, those performance issues exist anytime you make your domain too large. If you specify a varchar 5,000, when you really only need 100 characters. Anytime you specify the domain too large, SQL Server anticipates that you might have data that's actually that large, and there's some performance considerations that you need to take into account. Now that goes into quite a bit of depth inside the SQL engine, so we're not going to go to it in this session. If you'd like some more detail, you're welcome to ping me and we can talk about it. Or you can go and grab Kaylin Delaney's SQL Server Internals book, where she goes through some of the caveats and things you need to be aware of when you use the max data type, or when you create a domain that's too large even. Okay, so there we've covered char and varchar and the differences between the two, and when you would want to pick one or the other. Let's move on now to nchar and nvarchar. The first thing you're probably going to notice is that they look almost exactly the same, except that you have this n at the front. And really they are the same as the other two data types we just talked about. The character string has an n parameter. The limit here is 4,000 characters instead of 8, so it's exactly half. And the n relates to the size. In this case, it's 2 times n. So every character takes up 2 bytes, where with the char, every character only took up 1 byte. So we have basically half. We can go half as big, and the reason for that is we're using 2 bytes to store every character. It allows us to get a larger range of characters, all of the Unicode strings. The examples that I have here are the pi sign, the infinity sign, and symbols from other languages that you may want to incorporate. That's the difference between the nchar and the char, is the char is for non-Unicode strings and the nchar is for Unicode strings. So if you're going to be using a greater range of characters, if you're going to be supporting multiple languages and you're going to need to store Unicode values in your strings, then you want the nchar. Other than the ability to store Unicode strings and the restriction, not the restriction, but the storage space, the amount of storage required being doubled, the nchar and the char are the same data type. Likewise, your nvarchar is going to be the same as your varchar, the only change being that the nchar handles Unicode strings where the varchar does not. So the same decision process will come up here if you need to support multiple languages and you need to support an expanded character set, then you'll want the nvarchar. Just like the varchar, the nvarchar only stores the strings that you actually put into it. So if you declare an nvarchar 50, meaning that you want to store 50 characters, and you only put in 19, it'll only store those 19. You only store the storage hit for those 19 characters. It would be twice what it is for a varchar. 19 times 2 would be 38, plus a 2 byte overhead to give us a total of 42 bytes. But with that, you do get the support for Unicode. Okay, so let's talk now for just a second about these 4 data types. And again, review how you would pick one of these 4, whether you're developing an application or if you're going in to take the 7461 test and they want you to pick the correct data type for something that they've given you. If they say something such as you need to support Unicode strings or you need to support multiple languages, that's going to be a key that the answer is going to be one of the NCAR or the NVARCHAR. I neglected to mention the N actually stands for national. So the full name of an NCAR is national character, and the full name for NVARCHAR is national character varying. That's never going to come up on a test, but it is something that shows up in books online, so I thought I'd bring it up as a matter of interest and trivia that you can share with your coworkers. Hooray! Okay. So if on the test or if you're developing an application, you need to support character sets for multiple languages, or you know that you need to support Unicode strings, and that's going to be an indication that you need one of the N data types, NCAR, NVARCHAR. So that will separate it down to 2 choices for you. Between those 2 choices, when you're trying to decide whether it's the CAR or VARCHAR, or the NCAR and NVARCHAR, the choice there is on the variability in the length. If the length of your strings are always going to be static, we always put in a string that's 5 characters long. You always put in a string that's 100 characters long. Then your choice is going to be for the CAR or the NCAR. If your strings are going to vary a lot in length, then your choice is going to be VARCHAR or NVARCHAR. And that would be if one string might be 5 characters, but the next row might be 20, and the next row after that might be 80, and the row after that might be 7. That's enough variance, and typically you're looking at a variance of more than just a couple characters. That's enough variance that you typically go with one of the VARCHAR data types, either VARCHAR or NVARCHAR, depending on whether you needed Unicode support or not. So that's kind of the thought process that you can use to pick which data type you want to use. Now always, whether you're developing your own application or you're preparing for the certification test, you always want to choose a value, an N, that's going to be the smallest possible value that still encompasses all of the values you might get. So given the choice between, let's say, a VARCHAR 50, a VARCHAR 100, and a VARCHAR max, if you know that the data input that you're going to get is going to vary between 10 characters and 60 characters, obviously a VARCHAR 50 is not going to be big enough. A VARCHAR 100 would be big enough, and a VARCHAR max would be big enough. You want to pick the data type that's the smallest but still covers your domain. So the appropriate choice there would be a VARCHAR 100. All right, let's move on to our next 2 data types, which are binary and var binary. You notice that these look very similar to the data types above in that the binary has an N value and the var binary has an N and max. Let's talk for just a second about the binary. The N here indicates the number of bytes that you want to store, and again, that value is also going to determine the size, the amount of space that data type consumes. This data type is going to store binary data. The example that I have here is an image. A little small image of someone smiling, a little bit of teeth. So perhaps the type of information you might store in a binary data type would be a JPEG or a thumbnail or a PDF file or a Word document. Any kind of a binary file or binary data can fit into a binary data type. The values you can choose are, for the N, are 1 to 8,000. You can store up to 8K in a binary data type. And just like with the CAR and NCAR, whatever N you use, it consumes that much space for every instance. So if you declare a binary 5,000, but you only put 1,000 bytes into it, it still consumes 5,000 bytes of space because that's what you declared it to. It's set in its size. Now, just like with the VARCHAR and NVARCHAR, the var binary makes that variable. Instead of being a static amount, it only stores the actual data that you put into it. So in this case, if you created a var binary 5000, but only put 1000 bytes into it, the amount of storage space taken up would be the actual storage space that you use, and then 2 bytes in addition to that. So you had the 2 bytes overhead, just like you had with the varchar and nvarchar. So again, they store the same type of data, the difference being that the var binary only stores the amount that you put into it with the 2 byte overhead, or the binary has the same size regardless of how much data you put into it. Now the difference when you want to pick a binary or var binary is going to be the same as when you were evaluating to pick a car or varchar. It's how close each of your instances are going to be to each other. When you're putting binary data in, are all of the binary values exactly the same size? Do they vary by just a little bit, just a couple bytes, or do they vary quite a bit? Now in practice, what I usually see with this is that binary isn't used very often. When you're looking at storing binary files, particularly images or PDF documents or other types of binary chunks, typically they vary quite a bit in length, at least more than 2 bytes usually. So typically I see the var binary used more often than the binary. Usually where I see binary used are in very small amounts, where it's a binary 16 or a binary 32, where you have a specific thing that you're storing that's always exactly the same length. But in practical use, var binary ends up getting more use. So differentiating between these two is going to be the same as the same logic that you use differentiating between car and varchar and ncar and nvarchar. It's going to be based on the length of the data that you want to store it. All right. The last thing that we're going to talk about here are text and image. I'm blocking these in red because all 3 of these data types have been deprecated. Deprecated means that they will be removed in a future version of SQL Server. You've been given notice. They currently work in SQL Server 2012, but when the next version of SQL Server comes out, they may or may not have support for that. If you have a text column or an image column, you may or may not be able to use it in the next version of SQL Server. So they recommend that you don't use text and image for new development, and that as soon as possible that you remove it from your existing development. Part of the reason these data types have been deprecated is their functionality has really been replaced by the varchar max, nvarchar max, and var binary max. Those 3 data types store the same types of information that text and image did, with the advantage of having all of the functions and methods that you can call against a varchar now available against those larger data types. So there's really not any reason to use text and image anymore. And there's a lot of benefit from moving from those data types to their corresponding max data type, varchar, nvarchar, or var binary max. Okay. Just a thought for the test. If you're taking notes for the 7461 test, I would imagine that any question that had an answer of text or image would probably be incorrect if you selected on the test. As I sat down and was thinking about it, I couldn't come up with a question in my mind where text would be the correct answer. Never mind, I just did. If you're trying to support, let's see, when did they introduce varchar max? If you're trying to support a SQL Server 7 database, I don't believe they supported varchar max in SQL Server 7.0. So in that case, you would need to use text so that it would work on a SQL 7 database and in a SQL Server 2012 database. That seems like a stretch to me for a question that they would ask, and so I wouldn't expect it to be the right answer on any of the questions. So in your new development and moving forward, migrate away from it as you can, and in new development, use the corresponding max equivalent. Okay, let's move on to our next slide. These are some of the more grab bag and less frequently used data types. The first one that we're going to talk about is called a unique identifier. Some people will know this as and reference this as a GUID. A GUID stands for Global Unique Identifier, and usually it's pronounced out in its full name. At least when I've heard it, it's been pronounced out as a GUID, not G-U-I-D. It's pronounced as a GUID. Now the theory behind a unique identifier is that it's unique globally. So if I have a computer here in my office at my desk and I create a set of 10 GUIDs, each of those GUIDs should be different. Now you'll notice here that there's some commonality in these GUIDs. They have, they're using the characters, they're using hexadecimal characters, which are the characters 0 through 9 and the letters A through F. And they're separated into 5 distinct groups by a dash. So there are some commonalities. You can see here that I created these 10 GUIDs, and I actually used a function on my SQL Server box to create these GUIDs, and none of these are the same. They're all completely different. The theory is that if there's another computer somewhere else in the world that also creates a series of GUIDs, that their GUIDs will also be unique, but they'll also be different than mine. So a globally unique identifier, or a GUID, is unique throughout the world and throughout all space and time. So that if you continue to create GUIDs, you'll always get new ones and they'll never overlap. The purpose of a GUID is to allow you to create some kind of an identifier that you know will never have a match anywhere. So you know that it's going to be unique, and that even if there's another computer somewhere creating GUIDs, they will never create the GUID that you just did. Now, I will be honest, I have a background in statistics, and so anything where you say never, like there will never be a duplicate, I start to wonder. And I look at a GUID and I say, you know what, I can imagine that if I could create GUIDs really fast, that eventually I would create every single possible GUID, and there would never be a duplicate, and I would find a duplicate, excuse me. But I think the purpose, or the theory behind this is that it would be very difficult, for the first part, it would be very difficult to create a duplicate, and it would be very difficult to have those 2 duplicates in the same application being stored in the same place. So as you look at the probability of creating a duplicate, the probability is very small. But from a statistical standpoint, I think the possibility is definitely there. It can happen. It's just, will it happen to you? I think the chances are so low that everyone accepts it as being globally unique. So as you have GUIDs being created around the world in several different places, and here's a whole bunch of them flowing up onto your screen, none of these are the same. They're all unique. And that's kind of the purpose of a GUID, is to give you a unique ID. All right, so let's go back to our slide. A GUID is 36 characters here, but it's stored in 16 bytes. 16 bytes gives us actually 32 characters. The other 4 characters are dashes that are placed in a specific spot. So this is a 16-byte binary value. And it's used, the places where you'll see unique identifier used are in tables where you need to have a unique identifier for that row, regardless of whether there's a similar database somewhere else that's also tracking rows. So I would expect to see this on the test in a case where they say something like, you have 2 copies of your database that are exactly the same, one at your site and one at a remote site, and you need periodically to combine the data that you have with the data that they have so that it's all in one database, but you don't want to have conflicts. How do you make sure they won't have conflicts? Well, you can ensure that there aren't any conflicts by making sure that the ID that you use is a GUID, rather than starting with 1, 2, 3, 4, 5. You would have a 1, 2, 3, 4, 5 in your database, and they would have a 1, 2, 3, 4, 5 in their database, and so you'd have to do something special if you wanted to combine those together, so you didn't have 2 records with the value of 1. Well, you could use a unique identifier there, and that would allow you then to know that the IDs in your database are going to be completely different than the IDs in their database. Now, in my opinion, that type of a solution is a great theoretical solution, but not necessarily the best practical solution. You can go out and Google information about using GUIDs as primary keys in tables, and there are a lot of problems with it, particularly specifically in the performance realm. Using a GUID as an ID starts to impact the performance of your queries, your select queries. However, I'm going to guess, though, if you see an example on the test where it says you've got these 2 databases and they're separated from each other, you need to combine them together, make sure they don't have overlaps, they're asking you there if you understand what a GUID is. So on the test, you can go ahead and answer, yes, I think GUID is what you should use here, but know that when you come back to your desk and you start to sit down and work, a GUID may not be the best idea for performance as a primary key in your table. All right. Let's move on. Let's talk about rowversion. Rowversion is a very interesting data type. Again, it stores binary data. It has 16 characters, 0 through F, so it's hexadecimal values, and it's stored in 8 bytes. So it's very similar to a binary 8 or a var binary 8, because its size is always 8 bytes. What a rowversion does is it keeps track of changes in your table. And this is a data type and a column in your table that SQL Server will automatically maintain for you. Let's take a look. So here we have an example of a table, a customer table with 3 rows, 3 customers, and they each have their own name there: Jack O'Neill, Samantha Carter, and Teal'c. And each row has a row version. You can see that the row versions are different for each row in our table. Now, as we make a change to a row, perhaps we change the name for this row here from Samantha Carter to Daniel Jackson, SQL Server will automatically update the row version to be the next available value. If we assume here that this bottom row for Teal'c, the 7DA, is the most recent value, the next value would be 7DB. That would be the next value. And that's what SQL Server would put in there. This would help us to understand that that row had changed. Each change made to a row increments the row version for that row, so you can tell if a row's been changed. Now, this is commonly going to be used when you have an application that has the possibility of having concurrency. If, for example, I had one user that was using an application that was looking at the customer name for customer ID 2 and saw that it was Samantha Carter and made a change to it. Another customer was also looking at it and wanted to make a change as well. When they made their change, they could check to see, has the row version been updated yet? Oh, it has. Somebody else has already updated the name. Therefore, I need to make sure that I don't lose their update. I want to go ahead and refresh my screen and have my user realize that somebody else has updated that row. So this is a kind of a way of, if you watch the row versions, you can tell when a row's been updated. Now, if we had another table, in this case a product table that also had a row version, SQL Server keeps the row versions updated. It's a number that's kept in sync throughout the entire database, not just on a table-by-table basis. So with this new table, this product table, if we had an update here for this row number 1, updated the product name to be GDO, it would update the row version. It would take, again, the next available value. You can see here that the value that it took was the next one after 7DB, 7DC. So the row versions are not specific to a particular table, they are specific to a database. And as those row versions change, they will, as rows in different tables change, they will get increasing row version values in each one. So not only can you tell now whether a row has changed, but you can also tell which tables have changed. Using row version on multiple tables like this is most commonly done to find rows that have changed since a last update or a last sync. So for example, if you knew that the last time you connected up to the database, the maximum row version value in all of the tables was 7D9, sounds like 79, was 7D9, you could do a query through all the tables and say, give me every row in customer and every row in product ID and every row in, fill in the name of the next table here, that's larger than 7D9, and it would give you back all of the rows that had changed since the last time you looked at the database. It would give you the Daniel Jackson customer row and give you the GDO product row. And you could actually use the row version to tell what had changed in your database. Okay, so row version, 8 bytes, and it's used to keep track of changes. Row version, unique identifier is one that's used fairly frequently. With GUID. Row version is one that's not frequently used. There's some internal processes that I think will use a row version, but it's one that's not frequently used in production. So this data type is one that's a little bit more rare to see. All right, the next data type that we're going to talk about is called a hierarchy ID. Hierarchy ID is used to keep track of information about hierarchy structures. Let's give an example of what a hierarchy structure might look like. Here is an employee structure. You have Alex, who is our head boss, our CEO, and you have 3 people that report to Alex, Brad, Cindy, and David. David has 2 people that report to him, Jeff and Heidi. Cindy has 2 people that report to her, Evan and Frank. Frank has one person, Indigo has two people, Jake and Carlos. So here we have a hierarchy, a top level item, Alex, and structure down below him. There are many different ways to, well, there are not many. There are several different ways to represent this structure in a database, where you have one row for Alex, one row for Brad, one row for Cindy, one row for David. There's several ways to indicate the relationship to each other in the database. One of those is hierarchy ID. The way the hierarchy ID works is you create that column and you indicate for Brad, you say, Brad, I'm going to indicate who my parent is. Alex is my parent. Evan, I'm going to indicate who my parent is. My parent is Cindy. Cindy, indicate who my parent is. My parent is Alex. And you do that all the way through, each one specifying their parent. The way that SQL Server stores that information is somewhat similar to this, where it stores a path from whoever you are up your chain. So let's look at Carla here down at the bottom. 1, 2, 2, 1, 1, 2. Carla is the 2 here at the bottom. And her parent is the part in front of that, the 1, 2, 2, 1, 1. Well, who's 1, 2, 2, 1, 1? 1, 2, 2, 1, 1 is Jake. So Jake is Carla's parent. Jake is the 1. Jake's parent is 1, 2, 2, 1. So that her parent is Indigo. This doesn't quite look right. I think I did this wrong. Let me go back to my previous slide. Jake and Carla are siblings. Aha. So I'm going to do an in-place edit here. And this one right here should be blocked out. It should be, for Carla, it should be 1, 2, 2, 1, 2. So that you can see that the parent here for Jake and Carla should be common. The 1, 2, 2, 1 is common. Jake would be 1, Carla would be 2. Okay. Regardless of the error in my slide here that now needs to be fixed, SQL Server will handle putting the values in for the hierarchy ID. When you create a column here for David, you indicate that Alex is David's parent. SQL Server will remember that, and it will put in the hierarchy ID column the appropriate values there, and you don't actually need to see it or take care of it. What it gives you is the ability to now do queries and say, I have Jake, give me Jake and all of his lineage up. So it'll give you say, I want to do a query based on Jake and give me all the rows that are related to him. So we can go up and say Indigo, Frank, Cindy, and Alex are related. And it can do that very quickly. Likewise, it can go down. You can say, I have Cindy, give me anybody that's below Cindy. It'll give you Evan, Frank, Indigo, Jake, and Carla. And it does that really quickly. It's able to go through the rows very fast and discover this structure. So a hierarchy ID is intended to store a structure such as this, whether it's employee relationships or website menu tree or anything else that kind of fits this pattern. You can use a hierarchy to store that information. All right. What do you need to know for hierarchy ID on the test? I think you need to know what it stores. So if you have a question that says, you have this hierarchical structure that looks like a tree, what data type to use to store that? They're asking if I understand that there's a hierarchy ID data type. I do, and that's the answer. In real life, if you have a table that has a tree structure like this, I suggest you look at hierarchy ID. It's very good for some types of trees. There are a couple other ways of representing tree structures that you probably ought to look at as well. But hierarchy ID is probably a pretty good solution. Now I have here in parentheses CLR. Hierarchy ID is actually a CLR data type. I'm going to take this moment just to segue down here to user-defined CLR. You can actually use .NET languages like C#.NET to create a data type that's all your own. Perhaps you want to create a car data type, and you want to be able to store car information, and you have different properties and methods and ways of searching and sorting and manipulating that you want to implement. You can do that using CLR and create a data type called car. You're only limited by your imagination, and it has to be able to be stored within 2 GB of space. Actually creating a user-defined data type is beyond the scope of what we're going to cover in this class. There are websites where you can go out and see some very basic examples of how to get started and do it. And it's not too complex. But you can create your own data types. And that's what Microsoft has done with hierarchyid. They actually used their own implementation of the CLR user-defined data type to create a hierarchyid data type. And they've provided you with that data type native inside of SQL Server. So hierarchyid is a new data type that's actually built on .NET. There are two other data types that Microsoft has provided that are CLR, and those are geometry and geography. Geometry is used to store geometric shapes. The example that I have here is a triangle, a circle, a square, and a line across all of them. This is a single geometric shape. And using the geometry data type, or the spatial data types, you can actually store this figure with its dimensions inside of SQL Server. Well, that may be interesting, but why would you want to do that? Well, it may be that you have some kind of a diagram of a building or layout of a school district, and you want to represent that and you want to store that in a column. Well, okay, that's really neat, but what advantage does it give me to doing it that way as opposed to serializing it out into XML or some other data type? Well, you actually have some geometry methods that you can use to determine if two symbols overlap, or the area of their overlap, their union, or how close they are to each other, and their distance from each other. So there's their length, their circumference. There's a lot of different methods that you can call on your geometry data type native inside the SQL Server to actually do some computations. The other data type is geography. Geography is the same concepts as geometry. You have points and lines and triangles and squares. The difference between geography and geometry is that geometry, the first one here, is a flat plane. So let's actually do that. I'm going to type this out. Let's go back right here. Flat plane. Where geography is a spheroid. Hope I spelled that right. If not, somebody correct me. What I mean by flat plane and spheroid is that the dimensions that you use on a flat plane, the way you calculate distance and area and size, is a little different than if you're putting something on a spheroid. If you have a circle drawn on a bouncy ball, for example, or two dots drawn on a bouncy ball, and you want to compute the distance between them, it's a little different math than it is on a flat plane. Often the geometry is used when you're dealing with shapes and objects that are close to each other physically, and geography is used when you're looking at shapes, objects, and points that are on the surface of the Earth. This is where it's most commonly used. And you actually see here that this is a point, right? 39 and negative 111 is a point. But this really looks, I'm sure that most of you look and recognize this as latitude and longitude. And in fact it is. But it's really a point on a plane. But when you take that plane and wrap it around the Earth, then you get latitude and longitude and all the math that goes along with that. So the difference between these two data types are whether you're using flat plane or spheroid. I don't imagine you would see very many questions about hierarchyid, geometry, or geography on the test. It is important for you to know that those data types are available when you're doing your own development. And I think that for the purposes of the test, it's sufficient to know that they exist. I think that I would anticipate, and again, I can't make any promises because I haven't seen all the questions that could be on the test, but I would anticipate that if you see any questions on these three data types, they're actually asking if you know that they exist and know what they're called. So in this case, if you're looking at latitude and longitude points, I think they would say, hey, you've got latitude and longitude, you want to store it in SQL Server, what data type do you use? Do you use a float, a numeric 10,4, or a spatial? And you go, oh yeah, spatial exists, that's the geography data type, I'm going to go ahead and select that one. All right, let's move on now to XML. You can actually store XML native inside of SQL Server, and it's its own data type. We have a session coming up that's going to talk specifically about XML, an entire session for that. So I'm not going to go into it too much detail here, except to mention that it exists, and we'll talk a little bit more about the methods and the storage and when to use XML and when not to in another session. We have that one scheduled and planned. so you can look at that session to get more in-depth information on XML. All right, SQL variant. Those of you who are familiar with other programming languages that might have a variant data type will recognize what a SQL variant is. A SQL variant is a data type that can hold any other data type. You can store, in this example here, I have a numeric data type, 1, 2, 3, perhaps an integer, and then a string data type, an ABC. And you could have these data types be on different rows. You could throw a hierarchy ID into this column on one row, and the next row could be a geometry data type. It allows it to do just about anything. It's complete flexibility. Now, in practice, that makes your application really hard to use. In my experience and in my opinion, if you found a place where you think, oh, this is a good place for me to use a SQL variant, my guess is that you have some problems with normalization that you need to go back and look at and perhaps redo your data model so that you don't need to use the SQL variant. There are going to be performance and programming issues involved with that are probably going to overwhelm and overshadow the ease of just declaring it as a variant and moving forward. I don't know that I've ever seen a question where the answer on the test was SQL variant. Again, I think it's important for you to understand that it exists, and my recommendation would be that you don't use it, that you find another way around the issue that you have if SQL variant seems to be the solution that you're looking at. All right, we already talked about user-defined CLR, so or user-defined CLR data types, although the last one that next to the last one that we're going to talk about here are just user-defined data types. You can create, for example, an address data type that is a synonym for varchar50. And then you can declare a column as an address data type, and you can declare variables as an address data type, and know that everyone's using the same common varchar50. The purpose for doing this is to make sure that everyone's on the same page and that everything's consistent. You don't use a varchar50 for an address in one table and a varchar35 for an address in another table. Everybody uses the address. The address is defined centrally as a varchar50, and so they all end up being the same data type. In practice, sometimes this gets a little bit challenging. I believe in order to change a user-defined data type from varchar50, for example, to varchar75, you would have to actually go out and remove it everywhere where it exists before you could change it. So it gets a little complex if you need to work in an agile environment, but it is an option there that you can do. You can create synonyms for other data types. The last one that we have here on the list is a timestamp. Timestamp has been deprecated. It's the same thing as a row version, and so all you really need to do is change the text that you have for timestamp and change it to be row version, and you're set and good to go. Okay, here we have a pop quiz. So what I'm going to do here is I'm going to ask you to go ahead and think about the answers to these questions. Something we haven't done in our previous sessions, but go ahead and do this. I want you to create and assign a reasonable value for a variable that's holding, and then look at each one of these things. What data type would you use to store the date and time for a patient's appointment? What data type would you use to store the distance in meters between Earth and another object in our galaxy? So take a minute and think about each of these bullet points and come up with what you think might be the best data type for each of those. Now these will cover both the data types that we talked about in this session and the data types in the previous session where we went over numeric and date-time data types. Since I don't know how much time you need and I can't actually watch to make sure that you're done writing before I move on to the next slide, go ahead and pause the video at this point until you have finished, and then go ahead and unpause, and we'll take a look at what I did for each of these data types. Okay, here is the SQL code that I used to answer the questions in the quiz. The first question was data type to store the date and time of an appointment. Here I used a date time to 0. The reason I didn't use a date or a time is because we needed both of them together. I used a date time to 0 because it's more efficient than the date time data type. It stores a smaller amount of storage space. And I use 0 because I really don't care about the fractional seconds on this one. In fact, I don't want those. I do need to know what the difference between 10 o'clock and 10:15, but I don't really need to know the difference between 10 o'clock and 10 o'clock and a half second. So I don't need those seconds. So I used a datetime 2 for my data type. The next one was the distance in meters between items in our galaxy. And I used meters on purpose and galaxy on purpose because I wanted to find a number that was large enough you couldn't use a numeric. So in this case, you need to use a float, because a float is the only data type that can store a number large enough to store those distances between objects. In this case, I actually went and looked up the distance to Proxima Centauri, and you can see that value here is 4 times this really large number, whatever that number might be. And we can store that distance in meters between here and Proxima Centauri, which I believe is the closest star to us, other than our sun, in a float. All right, postal code. This is maybe a good time to interject that you may have picked some different data types than I did, and that's not necessarily wrong. If you had some justification to support it, and you had different assumptions than I made, you might very well come up with a different data type, and that might be perfectly fine for your implementation. Postal code is one of those. For postal codes in the United States, it's typically 5 digits and sometimes a dash and a 4-digit extension. So you end up with a total of 10 characters for a US extension code, or US postal code. Other postal codes around the world, and the one that I have the example here is actually one for Canada, have a mix of both numeric and character values in them. So you can't use a numeric value to store a postal code if you want to store international postal codes as well. And typically, for those of you who are in the United States, taking a US-centric view and using a numeric field is kind of short-sighted, and usually you want to think at least of some of the nearby countries around you and the postal codes that they might use when you're developing your application. Another reason for using a character field as opposed to a numeric field are the postal codes that begin with the number 0. That 0 will often be not truncated per se, but left out when you create a numeric value, and it's not there. So as you convert that back to use it, you would need to prepend zeros if they've been left off. And that becomes kind of a bothersome trouble for the application to make sure they always make sure they put the zeros on the front before displaying or using the postal code. So typically a character field is the direction you want to go. In this case, varchar 10 versus char 10 would depend on whether or not you know you're always going to have 10 characters on your postal code, whether you know you always have that 4 number extension, or whether it's sometimes left off. In this case, I said, well, we don't. This is something that the user is typing in. Therefore, some of them will only type in the 5 digits. Canadian ones will have 6. Some of them will have the 4-digit extension if we've looked it up. So we'll have a lot of variance in there. So I chose to use a varchar. If you made different assumptions, perhaps your data type would be a little different as well. Okay, patient name. I chose a standard varchar 30 because based on my infinite wisdom and research, that was supposed to be funny. No first name exceeds 30. So I don't plan on having any names longer than that. And so that seemed like a reasonable upper bound for the patient name. All right, storing a web page template. Here's another example where it might be, you might have picked a different data type than I did. In my case, I picked a varchar max. And I have a little example here of a very simple web page with just hello world on it. There are several other data types that might be valid depending on the assumptions that you made. Specifically, one of interest would be XML. And when we get to the session on XML, we talk about why you would pick varchar max or XML as your data type, and how to choose varchar max, XML, or var binary max as the appropriate solution. So based on assumptions you made, you might have picked something different. For me, I chose the varchar max. Okay, claim number. I gave you a little bit of information there telling you that the claim number would always be numeric. And so here you can make some assumptions that maybe we can use a numeric data type as opposed to a varchar. We don't have any character strings in there. I chose big int because I knew that our claim numbers might get larger than the 2 billion that an int can store. If you made some assumptions that claim numbers would remain small, then you could have chosen a smaller data type. Or if the claim numbers get big, you might have chosen something larger than a big int, one of the numeric data types. I don't think in this case that a float or a numeric with a decimal value would have been appropriate, because it wouldn't make sense that claim numbers would have those fractional or imprecise values that we would want to track. All right, data type to store the number of children in a family. Here I used a tiny int. Tiny int starts 0 and goes on to 256. That seems like a safe number for the number of children that somebody might have. I don't know anyone that has anywhere close to that number. So that seemed to be, based on the assumptions that I had, a tiny int was a reasonable data type to store the number of children in a family. Now the last one here is interesting. We had we asked you to store a file. Here the appropriate one would be a var binary max, because the size of those files, I think we can safely assume, are going to vary quite a bit. So a binary value isn't going to necessarily be, one, large enough, the maximum of 8,000 bytes or 8K. It's a good chance that some of our files will be larger than that. Plus, they'll vary a lot in size. So using a var binary max allows us to exceed the 8K limit of binary max, but also only incur the storage space for the actual file plus that 2-byte overhead. All right, let's go back to our slides now. I'm going to talk for just a minute now about conversion and naming. The implicit and explicit conversions, cast and convert, and type precedence, I have a demo that I want to talk about. When we come back from the demo, we'll talk just a bit again about null. I think we've already gone over it once. We'll do it again. And then I'm going to explain what I mean here by drop table. So let's first go and talk about implicit and explicit conversions. An implicit conversion is a conversion that SQL Server does for you. You have two data types, and you're using them together. And SQL Server will convert one of the data types to match the other so that it can use them both together. An explicit conversion is when you tell SQL Server exactly how you want and when you want the conversion to occur. Let's go look at some examples. The first thing that I want to show here is that you can't always tell the data type from the output in Management Studio. Here I have two select statements. The first one has the numbers 1, 2, 3, 4, 5 inside of single quotes. The second one has it outside of single quotes. The results here look the same for both, but they're really not. This first output here is 1, 2, 3, 4, 5 as a varchar, or character string. The second one here is 1, 2, 3, 4, 5 as a numeric. So these are different data types. Even though they look exactly the same, the data type is different. It's very difficult from the output to determine what the data type is. All right, let's look at an implicit conversion example. Here we're going to take two numbers, 1, 2, 3, and 6, and we're going to add them together. What is the result that we get? The result that we get is 1239, 129. SQL Server took this string, 1, 2, 3, and converted it to a numeric value, and then added the 6 to it. Well, what happens when we do the same thing when we add, but we have strings on both sides? Here I'm going to take a first name, which is car4, and a last name, which is varchar10, two different data types, and I'm going to add them together with a space. So to the first name, add a space, then add the last name. In this case, SQL Server appended it. The space that we added is right here between the first and the last name, and it appended all of these strings together. So the plus sign here can mean different things depending on the data types on each side. The SQL Server implicitly converted these data types to each other. Now let's take a look at another example here. Here I have a birthday variable that's a date. And I have a string birthday variable here that's a car10. What I'm going to do is I'm going to assign the date variable to be equal to the string. So this is telling SQL Server, take the character string and push that value into the date variable, and then show me what the result is. Okay, when we run that, what we get is April 10th, 1981. So it successfully did that. It converted my string into a date. Now what I'm going to do is I'm going to set the date directly to be February, March, April, May 5th, had to count, 1991. And then I'm going to go the other way. I'm going to say, now take that date and push it into the string and show me the string. I'm going to highlight all these so we'll see the April 10th again, and we'll see the output here. Again, it converted that May 5th to May 5th, 1991 as a date. So here's an implicit string to date and date to string conversion. Implicitly, we didn't tell SQL Server how to do it. It did it for us. Okay, now let's take the same sort of an example, but in this case, time, instead of using a date, we're going to use a date time. And instead of using a character string, we're going to use a big int. And the big int is 1, 2, 3, 4, 5. So what happens when we try to convert, we push that int value into the date time, what does SQL Server do with it? Well, it actually converted it to a date, January 5th, 2238. SQL Server can convert from an int to a date time, but you don't always know exactly what you get out of it. Okay, let's do an implicit conversion the other way. Let's go from a birthday, May 5th, 1991, back to a integer and see what the integer looks like. Let's go in the other direction. Well, that one is not allowed. Well, very interesting. Well, why was it allowed one direction and not allowed the other direction? We can actually turn to Books Online to find that. Let me open that up for you and show you the conversion table. Here in the Books Online for Cast and Convert, if we scroll down a little bit, we can actually see that there is a table. There is a table that shows the types of conversions that can be done implicitly by SQL Server. So if we look at the date time row, going from date time, and we follow across to an int, which is right here. But this requires an explicit conversion. However, if we go from int and then go over to datetime, we can see that there it allows an implicit conversion, the light gray box versus the dark gray. This table here tells us what data types can be implicitly and explicitly converted. All right, let's go back to our example. Okay. So now let's go ahead and do an explicit conversion. We do an explicit conversion by using the convert function. And we tell it what data type we want it to go to, and then we pass in the value. So this will do an explicit conversion. It's like the table told us that we should be able to do, and there it is. We converted that date into a value. Now convert is one function that we can use to take data to and from different data types. The other one is cast. Let's look at some examples using both of these. With convert, like I did up here with the date time to big int, you indicate the data type first and then the value that you want to be converted. With cast, it's the opposite direction. You give the value, the word as, and then the data type. So both of these work the same way. So with both of these, we'll get an integer data type out from the character that we passed in. Cast and convert work almost exactly the same way, with one exception. And the exception that I have is the example I have here down at the bottom, this next one, and it is when you're casting a date time back to a character string. When you're casting or when you're converting a date time to a character string, you get to determine how you want that date to come out. Let's look at these different examples. For this first one, I converted the current date and time, so now you know that I created this presentation August 6, 2013, and I converted that date and time using a format number 109. And that format gave me a spelled out month, AUG, then a space, and then the day, then the year, then the hour, the minute, the second, and 7 fractional seconds, and an AM, PM identifier. That's what 109 means, is converted this way. The same date and time, using a format 110, just gave me the month, day, and year, with zeros preceding single-digit months. The same date, 111, gave me year, month, day. 105 gave me day, month, year. Now, those of you who work with internationalization will recognize that these are different formats for different countries. Some countries like the year first, some countries like the month first, some countries like the day first. And you can use convert to take your date string, convert it to a string in whatever format it is that you need. Now this one here, this 131, you may recognize it's a very different date. SQL Server has some conversions. In this case, this is a conversion to, and I apologize, I'm going to pronounce this wrong, but it's, I'm going to do my very best. It's a conversion to the hierarchyid calendar, which has a different starting year than the Gregorian calendar. So converting today to the hierarchyid calendar, it's actually this date and not the others. Now, you can get information about these formattings back on that Cast and Convert page in Books Online. And it will show you an example of each of the different types of styles that you can change, you can cast and convert your date and times to. When we get to the section where we talk about functions built in SQL Server, there's another function that we can, that's new in 2012, that we can use to convert date times that uses the .NET format strings. And that's another option that we now have in order to format dates and times. Okay, back to our example. Let's look at some fun stuff here. We're going to do a select here, hello plus world, just like we saw with the previous example with the names. When you use a plus, then you're converting, instead of adding together, it appends those together. So here I have hello plus 5. Oops. Sorry. Here I have hello plus 5. This doesn't work. Well, why doesn't it convert that and give us hello 5 back? It's a string and a number. It should just give us hello and the number 5. It should append it. Well, if you read the error here, what it says is that the conversion failed. Let me expand this up just a bit. Conversion failed when converting the varchar value hello to a data type int. So we tried to convert hello to a number, and it couldn't do that. It was going to try to convert it to a number and then add that mathematically with the number 5. Well, why did it choose to go that way instead of converting 5 to a string and then just appending? Well, it did it because of data type precedence. Each data type in SQL Server has a precedence value, an order, if you will. And data types of lower precedences are converted to data types of higher precedences. Let's go take a look at Books Online and see their list. This is the list of data type precedents in SQL Server. So if we go and we look and we find our varchar, here is number 27. The 5 that we had was an int. Int is higher up the list than varchar. So whenever we put a varchar and an int together, it's going to try to convert the varchar up to be an int. In this case, the word hello, it couldn't convert to be an int, so our conversion failed. This is a handy list here to have when you're working with different data types to determine how the conversion will happen. An int will never be implicitly converted to a varchar. A varchar will always be implicitly converted to an int. So how do we then get what we want? Let's go back to our example. If we wanted to get this to work, what we need to do is convert varchar to 5, and then using an explicit conversion, then it will append it the way we wanted it to. Now here's the situation where you'll see this, and this is something that you need to watch out for, and here's an error that now when you see this error you'll know exactly how to fix it. This error happens when you have a field, a varchar field, that contains both numeric and text values. So here I'm creating a small temporary table called data type clash. It has a key value here, an integer, and then it has a value field, which is a varchar 50. The first row I have the characters 543. In the second row, I have the characters no value. Now, when I try to do a select out and I want to find the rows where the value is 543, here I'm going to get the error again. Conversion failed when converting no value to data type int. Well, this field is a varchar field. What I wanted was to find the 543, which is a character. But what I passed in here was an integer. This is an integer. The value is a varchar. Varchars have lower precedence, therefore my value needed to be converted to an int. And it couldn't convert the no value to an int to see if it was a 543, so it gave me an error. The solution here is to give it a character field as well, so that now we're comparing a character value with a character string. And then the select will work. When we get to the session, where we talk about indexes, we can also talk about this there as well. If you have an index on a field, on a varchar field, but you pass in an integer value like we did here before, if your values can all be converted to numeric, they will, but it won't use the index that you have on the field. All right, let's go back to our slides. Okay, so we have talked about implicit and explicit conversions, cast and convert, and type precedence. In a previous session, we talked a little bit about what null was, and I want to cover it again here. A null means unknown. When you have a null value in a table, it doesn't mean 0. It doesn't mean nothing. It means unknown. You remember the example I gave previously is a box that I'd bring to class, taped shut and covered with brown paper, so you can't tell what it is. And I ask somebody in the class, I say, here, take this box, tell me what's in it. And they say, well, I don't know what's in it. Well, is there something in it? And they'll shake it and they can hear something rattling inside. So they know that there's something inside, but they don't know what it is. And I pointed out that that's a null. A null means there's a value, but I don't know what it is. It doesn't mean 0. It doesn't mean no value. It means unknown value. So when you're deciding whether or not to allow nulls in a column in your table, that's the question that you want to ask. Do I want to allow an unknown value into my table? If you need to allow that, then you can allow nulls. All right, the last part here I have is drop table. Now what I want to point out here is that drop is in brackets and table is in double quotes. This is something that's very important for naming. There are some words that are reserved keywords in SQL Server. You don't want to name a table drop. You don't want to name a column in your table, because then it gets confusing when you're writing out your SQL statements what you actually mean. If you use the word table, do you mean the column that's named table, or do you mean the object that is called a table? So typically when you're naming your objects, your stored procedures, your tables, your columns, your indexes, you avoid using those keywords. And if you look in the books online, you can very easily get a list of all those keywords. And often Management Studio will highlight those for you and let you know that, hey, that's a keyword. If you do use a keyword, but as either the name of an object or the name of a column or the name of stored procedure or the name of a table, you can reference that using brackets. In this case, putting brackets around the word drop means I'm not looking for the function drop, but I'm looking for an object named drop. The same goes for double quotes. I'm not looking for an object, or excuse, I'm not using the keyword table, I'm looking for an object that's named table. That can get very confusing, so please don't do that in your own code. But when you script out objects in SQL Server using Management Studio, you'll notice that it puts brackets around the object names. And that's what it's doing, is it's putting it around that to make sure that any odd things in there, a space or a special character or a reserved keyword, it can actually be referenced appropriately. All right, if you have any questions about the data types that we discussed today, feel free to contact me, and I'll do my very best to answer your questions. You can either drop by and see me at my desk, and we'll talk in person, or you're also welcome to either send me an email or send me a short note on Twitter at @UVAChat. Thank you, and we'll see you in the next session.